A couple more examples of partial fraction decomposition. So this time we have 4x squared minus x plus 1 over x plus 1 x squared plus 2. Now, I want you to notice that this time we have one linear factor, but one quadratic factor. And this is a prime factor, okay? So because it can't be factored, then we're going to have to set this up differently. Our decomposition for this, for the linear, it's going to be a over x plus 1. But for the quadratic, it's going to be bx plus c over x squared plus 2. Right? And so what we're going to do now is just like we've done before, we're going to multiply through by the common denominator. In this case, it's going to be x plus 1, x squared plus 2. So I'm going to multiply this by x plus 1, x squared plus 2. I'm going to multiply this by x plus 1, x squared plus 2. And then surprisingly, I'm going to multiply this by x plus 1, x squared plus 2. And we're going to cancel. Right? Those terms cancel. X plus 1's cancel. X squared plus 2's cancel. Right? So what's the resulting equation? Well, we're going to end up with the numerator on the left-hand side, which was 4x squared minus x plus 1. On the right-hand side, we have a x squared plus 2, which isn't terrible. And we have this bx plus c times x plus 1, which could be a lot worse, but isn't as nice as we'd like it to be. We're going to FOIL out the right-hand side. Okay, so this now becomes a x squared plus 2a. And then we're going to have to FOIL this. Okay, so we get bx squared plus bx plus cx plus c. Now we get a system, okay, just like we've seen multiple times before, all right? This system's going to be a little bit more rigorous to solve, but it won't be too bad. So we look at the x squareds. We have 4ab, okay? So we have a plus b is going to be equal to 4, okay? That takes care of the x squareds. For the x's, we have bx plus c. So we have b plus c is equal to -1. Okay, so that's the coefficient here of the x. And then finally, terms that have no x's in them, 2a plus c. And that's going to be equal to +1. All right. Now, how do we solve this system? Well, what we could do is we could just solve either of the first two equations for either b or c, and then we could substitute back in. Okay. Um, it looks like what we could do is let's just solve this second equation for C. Okay, I don't know if there's a better way to do this. So that's going to be -1 minus B. And I'm going to plug that back in right here. Okay, and so now the first equation, A plus B equals 4, stays. The second equation, 2A minus 1 minus B is equal to 1. Okay, so notice what we did there, folks, was we just substituted back in for C. If I add 1 to both sides, that means I get a system of A plus B equals 4, 2A minus B equals 2. B's cancel out. I get that when I add these equations together, I get 3A equals 6, divide by 3. A is equal to 2. Really nice. We know that A plus B is 4. So 2 plus B is 4, or B is also equal to 2. Finally, we know that 2a or b plus c is -1. We could use either of these. I'm just going to use this one because it's a little more simplistic. So b plus c is -1, which means that 2 plus c is equal to -1. C equals -3. We go back up. We substitute for a, b, and c. Remember that a is 2, so we get 2 over x plus 1. Remember that b is also 2. All right, so we're plugging back in here. So we have bx plus c. C is -3. And the denominator for this was x squared plus 2. Right? That's going to be our decomposed fraction. Okay, again, all I did was I just substituted back in for A, B, and C when we decomposed those fractions. Okay, so not too bad with this one. A little bit rough on the system, but we've solved systems for a while now, so it shouldn't be too big of a deal. One final example of partial fractions, x plus 24, x to the fourth plus 6x squared. Now notice that this denominator is not prime. It can be factored. In fact, I can factor an x squared out of that, and that'll leave me with x squared plus 6. The numerator is x plus 24. Notice that we have a linear repeated factor, okay? Since x is x and then x squared, and then this is going to be a distinct quadratic factor. So if I set this up for decomposition, I'm going to have a over x, b over x squared, and then cx plus d divided by x squared plus 6, because that's a quadratic factor. Okay? Now I'm going to multiply everything by x squared x plus 6, okay, or x squared plus 6. All right, so a little bit painful. All right, but what's the saying? If it doesn't kill you, it makes you stronger. All right, so it's just able to squeeze that in there. Everything cancels on the left side. That's good. One x is going to cancel. Both x's are going to cancel. And then x plus 6 is going to cancel, or x squared plus 6. I keep saying that. All right. So this system isn't going to be as bad as the previous. Okay, so we have x plus 24 on the left-hand side. We have ax, x squared plus 6, b, x squared plus 6, and then finally, cx plus d times x squared. Okay, so we just have to be careful with this as we go through here. All right, now finally, we're going to distribute. Okay, so we get x plus 24 equals ax cubed plus 6ax. Right, forgot to squeeze the a in there. Okay, so ax times 6, 6ax, plus bx squared plus 6b plus cx cubed plus dx squared. All right. Now, notice that we're missing a couple powers. We have an x cubed and an x squared on the right-hand side, but on the left-hand side, we don't. So we need to fill in those powers. So I'm going to fill that in with a 0x cubed and a 0x squared. Now we're ready to create our system. Okay, so just like we did really early in the course with long division, we need to do the same thing here. All right, so we notice that we have a couple x cubes here. Okay, so we have an a plus c, which is going to be equal to 0. For our x squareds, there's a couple x squared terms. So we're going to get b plus d is also equal to 0. Right, so those are pretty nice. Even easier, we have 6ax is equal to x. So we have that 6a is equal to 1. And then finally, we have this 6b is going to be equal to 24, because that's the constant that we have left. Right? So now we solve. Okay, clearly the latter of the two equations are pretty easy. Okay, so a is going to be a 6th, b is going to be 4. Now notice that the opposite of a is equal to c. Okay, so we can just subtract a, or in other words, that means that c is negative 1/6. Notice also that d is the opposite of b, just by adding or subtracting b from both sides. And so that means that d is going to be negative 4. We go all the way back up to the beginning. Remember, a was over x. Okay, so we have 1/6 over x. Remember that b was over x squared, so 4 over x squared. And then we had cx plus d, so minus 1/6 x minus 4, okay, divided by x squared plus 6. All right, now, this is a little bit sneaky where we go through and try to simplify this, okay? So the first one's easy, 1 over 6x. The second one's even easier, 4 over x squared. Right? What I'm going to do is I'm going to factor from here, all right? And this is really sneaky. I'm going to factor a negative 1/6 from the numerator, okay? Now, if I factor negative 1/6 from 1/6, that's going to leave me with x. That's going to leave me with 24 over here, okay? So negative 1/6 x plus 24. Now, if you don't trust me, negative 1/6 times 24 is negative 4, not negative 1/4, okay? So that's what you want to do is when you're doing this, just think to yourself, or you could just take negative 4 divided by negative 1/6, or negative 4 times the reciprocal, which would be negative positive 24. All right, so this could be written as plus negative 1/6 times x plus 24 over x squared plus 6. And so finally, I think the most simple answer we can get from this is 1 over 6x plus 4 over x squared minus x plus 24. So this is going to be an x plus 24 in the numerator. In the denominator, 6 quantity x plus x squared plus 6. All right, so that's the most, I guess, simplified, decomposed expression we can get out of this. Okay, all right, so that's going to be everything for our partial fractions in this section. Okay, so first thing I would recommend is if you're struggling with these, go all the way back to the beginning and remember what it means to divide, to set these up. Okay, then just be careful with your algebra as you're going through. Okay, since we just did systems, systems shouldn't be that big of a deal for most folks. Okay, but again, be careful with the foiling right here. Okay, that's usually one of the areas where students struggle a little